Okay, so I wanted to kind of try and gauge the sentiment in the Bitcoin Cash community about, I guess, sort of the usefulness that people feel surrounding particular feature. And that feature is stealth addresses. So I know we have quite a bit of people who are kind of new to Bitcoin, certainly new to Bitcoin Cash. Stealth addresses are a scheme that was created, I think, all the way back in like 2013 now. And there was kind of a lot of discussion about them way back then, and then nothing ever really came of it. I think they were implemented in one alpha wallet, or at least partially implemented in an alpha wallet, if people remember Dark Wallet. So nothing serious ever really came from it. And maybe rightfully so. I mean, maybe stealth addresses have like very little usefulness, and we'll see. But I just kind of create a little demo here. I just wanted to sort of talk about it a little bit. For those who aren't aware what a stealth address is or what it does, the name is very misleading, right? It kind of gives the impression that stealth addresses are somehow kind of like more private than regular Bitcoin addresses, and that's really not the case. What stealth addresses are doing is they are kind of trying to provide a solution to sort of a very particular use case for Bitcoin, or in this case Bitcoin Cash, and admittedly this might be kind of a little bit of like a niche use case that it's trying to solve, but just a little bit of refresher when it comes to privacy in Bitcoin. We tell people not to reuse addresses, right? That anytime you reuse addresses, it's kind of a bit of a privacy leak, because anyone can kind of enter that address into a block explorer and they can see your whole transaction history. So the way nearly every Bitcoin wallet works today is that whenever you receive a payment to the wallet, to an address from that wallet, that the wallet marks that address as used, and then it generates a completely fresh Bitcoin address to kind of queue up for your next payment. And so this kind of prevents, what we just mentioned, where people can just enter your address into a block explorer and see your entire transaction history and your balance and what have you. And that, for the most part, works fine. I mean, this is how wallets work. No one's really kind of complaining. But there is kind of one use case where this doesn't really work, and that's like, let's say you wanted to print an address into, like, let's say a QR code. And I don't know, maybe you wanted to make up some flyers that have your Bitcoin address or Bitcoin Cash address in a QR code. Or maybe you have I don't know, you have a table where you're selling stuff at like a yard sale or something, and you just want to have a QR code for people to send payments to. Or maybe a little bit real world example, right down the street from me, there's this kind of like, I don't know, libertarian club, I guess you could call it. And they have a fridge in there that's just kind of loaded up with beer and other stuff, and there's just like a QR code stuck to the outside of the fridge, and it's kind of like honor system. You just, whenever you grab a beer, you just send the payment. But in each of those cases, you have a static static address in a QR code, and anyone can just kind of scan that address, and you can see the person's entire transaction history and how much money they've made and what have you. And for privacy reasons, this is not ideal. So this is essentially what stealth addresses were kind of, at least invented, I guess you could say, or what they were trying to solve, is the ability for someone to publish just a single static address, but then what would happen is the sender's wallet would generate a new, fresh, unused Bitcoin address to actually send the payment to, and would send the payment to that address, and then the recipient's wallet would have a way of detecting what address that was that the payment was sent to, and could do so in a way using kind of clever cryptography, could do so in a way where only the recipient could derive the private key for that address. So it's where the sender could basically derive the public key to the address. He wouldn't know the actual private key. Only the recipient could derive the private key and recover the funds. So it's a pretty clever use of cryptography and with the Bitcoin protocol, in that you can everyone can basically have a single address and still receive payments to a new address every time. as a result of this. Now, way back in like 2013, a lot of the discussion was about, how to try and make this compatible with light clients or SPV clients. And I think the conclusion at the time, if I remember, was pretty much that you couldn't do it without like broader changes to the actual protocol. That essentially you had to run to receive payments to a stealth address. You had to run basically a full node that would scan every single transaction and check to see if it was for you, basically. Or the alternative would be you could give your stealth address to a trusted third party who could scan the blockchain for you and tell you all your addresses. But without any kind of broader protocol changes, this wouldn't be possible with like lightweight clients. Well, actually turns out not to be true. So I've kind of figured out a way to do it with SPV clients. So you can see example, I have 2 SPV wallets running right here, and this doesn't require any changes to the Bitcoin protocol at all. So these wallets they're not connected to a server, they're not connected to any trusted nodes or anything. They're just connected directly to the Bitcoin Cash mainnet, which would be Bitcoin ABC and Bitcoin Unlimited peers. There's no changes. This is just how the protocol works today. And so I can just kind of give you an example of this in action. Okay, so what I've done here is this is the new cash adder format that we're using for Bitcoin Cash addresses. One of the nice things about it is this is designed to kind of be extensible and allow for new types of Bitcoin addresses. So I've kind of gone ahead and like extended this here and created a new address type for a stealth address. And you can see it's a little bit longer than the normal cash address because it's got a little bit of different data in there. But essentially, all you have to do is send a payment directly to this address, and we'll see what happens. So, so this one has, I have to specify the port on this one. So this one I have a balance on, okay? And if I can do... I'm going to send it to this stealth address. And maybe I'll send about 10%, maybe 90,000 Satoshi about. Okay, so, and if I check with this one, okay, there's my unconfirmed balance of 90,000 Satoshi. So if I take this transaction ID here and look this up on the blockchain, right, this is the Bitcoin Cash mainnet. Right, here's my transaction. So this is my address where the 90,000 Satoshi were sent. And we can see that we've got a little bit of metadata I had to embed in this transaction in op return down here. And this is basically the cost of these stealth transactions. That requires about, in this case it was about 52 bytes extra to be included in the transaction versus what it would have other been if it, or how much data it would have used if this was a regular transaction. So this is 277 bytes. This obviously would be 52 bytes less if this had not been a stealth address. So that works out to be, I think it's around, like, for this transaction, it's about maybe like 23% larger than it otherwise would be. And I guess the primary cost of that is it's primarily bandwidth. It's bandwidth on the Bitcoin Cash network. Full nodes don't actually do anything with this. They just ignore this metadata, so there's no real kind of CPU overhead related to this. There is some storage overhead, which is, if you're trying to archive the whole blockchain, there would be some additional storage overhead. But the primary overhead is just maybe about 23% more bandwidth related to this transaction than we otherwise would have. And so if everyone obviously used the stealth address type, that mean we'd get like around, 20% or so less transactions for the same amount of bandwidth usage. So that's the trade-off, right? More bandwidth usage in exchange for this kind of maybe a little bit more interesting transaction type. Is that worth it? Is that cost worth it? I don't know. It's maybe you guys can answer that question. And again, it's interesting, but it may only be useful to kind of more like niche use cases where you have to, publish a static address somewhere. And just to give you another example of this, if I do this again, I'll make another transaction. Maybe I'll send, we'll do 80,000 Satoshi this time. But I'm going to send it to the same address here, the same stealth address. Okay. And let me put this over here. Okay, so here's my 80,000 Satoshi, and if we notice that this address that the funds were sent to was different than the address that the funds were sent to in this transaction, which is where essentially how the stealth address works. So we're sending it to a new address every single time, even though we're just entering the same stealth address to actually send the payment to. I'm going to check my balance over here, and there we go. Right, there's my 2 transactions that I received. Okay, so it's pretty cool, and it's pretty cool that this works on the Bitcoin network today without any changes at all, right? There's no protocol changes needed to use this. The only thing that would be needed if you actually wanted to use this would be pretty much every Bitcoin wallet would need to be upgraded to know how to send to this address type. They don't necessarily have to use it themselves, but they would have to know that when they see this address up here, they'd have to know how to actually parse that and how to actually send a payment to that. So unless other people were going to adopt this address type, it wouldn't actually go anywhere. So I guess the question, for the community is, do you see any kind of value in this? Is it worth like people implementing and putting in their wallets, given that it doesn't actually require a protocol change? Is the cost worth the benefit? I think one thing, maybe kind of side benefit that can potentially come out of this is, we do know that lightweight wallets like these SPV clients have some privacy issues surrounding the use of their Bloom filters, right? And basically the problem is we want to download the transactions that are for our wallet, but without kind of telling the peers that we connect to exactly what addresses we're interested in. And the current methods for doing so, they don't really work that well. And so you end up kind of in certain ways sort of leaking information about what addresses are in your wallet to your peers. One possible way around that could be to use these stealth addresses exclusively for a lightweight wallet in a kind of a form of prefix filtering. So kind of what I'm doing with the op-return data right now is I'm doing like op-return, and then I've got this metadata here. It's an ephemeral public key. And then I have this like flag, and the flag is to kind of signal, who this transaction. It's a few bits signaling who this transaction is for, and I stick this flag in a Bloom filter basically, and that's what's basically triggering a filter match. So if multiple people use this same flag, then you have some overlap between other people. So you're filtering your transactions, but the peers don't really know which incoming transactions are for you or are they for someone else if you have people using the same flag. Now, in order to actually build a functioning wallet, you also need outgoing filter matches for outgoing transactions. So what you could possibly do is do something like, if this is a stealth transaction, you would do maybe the recipient's flag, and then you could have the sender flag in here as well. And then your Bloom filter would only contain your flag, and that's it. And from a privacy perspective, you wouldn't be leaking data the way you currently do with your with the normal Bloom filters, right? That your anonymity set would be however many people happen to be using the same flag as you. So that's one potential way to kind of solve this problem regarding privacy with Bloom filters, albeit there's a cost to that of more bandwidth and slightly larger transactions as a result of that. So yeah, I don't know. You guys can tell me if you think it's useful, if it's something that is worth pursuing. As we move forward with Bitcoin Cash, let me know.